Welcome to this explainer. Today, think of me as your principal architect, and together we're going to dive into a rigorous, scenario-based master study plan. The ultimate goal, to help you completely ace your software design exams and fundamentally transform how you approach system architecture. If you've ever stared down a massive, complex software dilemma and just wondered, which design pattern do I even apply here? Well, you are in exactly the right place. Let's get started.
Here's our roadmap for today. First, we'll cover the diagnostic matrix. Second, a deep dive into the core trio of patterns. Third, we'll hit the scenario practice suite, followed by a strategic decision framework. And finally, we'll wrap up with the practice answer key. We're gonna move fast, so stay with me.
Section 1. The Architect's Diagnostic Matrix. Let's make some sense out of the chaos of software design.
Think of the software engineering landscape as being built on three main pillars. First up, you have creational patterns, which are entirely focused on how objects are instantiated, giving you that much-needed flexibility in creation. Next, we have structural patterns. These deal with the composition of classes and objects, organizing them into larger, flexible structures. And finally, behavioral patterns, which are all about the dynamic communication and responsibilities between your objects.
Now, consider this your ultimate exam cheat sheet. You absolutely need to memorize these trigger phrases. When an exam scenario mentions bridging incompatible interfaces, your brain should instantly anchor to the structural category. If a prompt talks about needing exactly one instance of a manager, boom, you're in creational territory. And if you spot phrases like one-to-many updates or interchangeable algorithms, you know for sure you're dealing with a behavioral problem. Simply recognizing these symptoms, that's honestly half the battle.
Section 2. Deep dive into the core trio. These are three high-yield patterns you are almost guaranteed to encounter, both on your exams and out in the real world.
Let's kick things off with a real creational heavyweight, the singleton. Imagine a realistic system bottleneck where multiple modules in an application are all desperately trying to open their own database connection. It's a mess. This creates inconsistent states, duplicate connections, and eventually total system crashes. The blueprint of the singleton strictly enforces exactly one secure, global instance of a class that is shared safely across the entire application.
Notice how completely different modules, say Client A, Client B, and Client C, are all forced through one single access point to reach that centralized database or service. It entirely eliminates the risk of those rogue duplicate connections taking down your system.
Now, jumping over to the structural family, let's talk about the facade pattern. The main headache here? Micromanagement. Imagine making your end user manually turn on a DVD player, dim the lights, boot up a projector, and route the sound system just to watch a movie. It's an awful, tightly coupled user experience. The blueprint solves this beautifully by providing a unified, simplified watch movie interface that wraps all those complex subsystems into one single clean command.
The facade is basically a protective shield. The user only ever talks to the facade, completely hidden from the tangled underlying logic of the DVD player, the projector, and the lights. The facade takes on all the burden of coordinating that complex subsystem so the client doesn't have to worry about a thing.
And finally, a true behavioral titan, the observer pattern. The architectural bottleneck we're looking at here is rigid, tight coupling in notification systems. If a company needs to send critical alerts via email, a mobile app, and a web dashboard, directly wiring the sender to every single receiver creates an absolute maintenance nightmare. Our blueprint fixes this by creating an automated one-to-many broadcast mechanism. A central subject simply pushes updates out automatically to any registered observers.
Just look at how seamlessly new channels can be tacked on. Because the subject is simply broadcasting to a list of subscribers, you can plug in a brand new display screen or a smartwatch notification without rewriting a single line of the core subject logic. It makes the whole system incredibly flexible and loosely coupled. But here is a massive warning sign straight from Dr. Shamim H. Rippon's lecture material: avoid overuse. Honestly, this is the biggest trap for junior architects. Patterns are meant to solve real bottlenecks. Injecting a singleton, a facade, or an observer into a simple system that doesn't actually need it, that doesn't make you look smart, it just creates unnecessary complexity and a massive maintenance headache down the line. Please do not force-fit them.
All right, Section 3, the Scenario-Based Practice Suite. You are officially in the hot seat. I'm going to present 6 rapid-fire scenarios across various engineering domains. Your job is to test your pragmatic selection skills and pick the right pattern. Ready? Let's go.
Scenario 1. You are building an e-commerce platform. Your payment module requires interchangeable plug-and-play algorithms so the user can switch seamlessly between a credit card, Bcash, or PayPal right at checkout. What is your architectural choice for this behavioral problem?
Scenario 2. You're working on a UI framework. You need to dynamically wrap new behaviors, like spell check and autosave, onto an existing base text editor object, but you absolutely cannot alter its original source code. Which structural pattern handles this kind of dynamic addition?
Ah, a classic enterprise dilemma. Your modern application expects a specific payment processor interface, but you are forced to integrate a legacy third-party API that fundamentally mismatches what your system expects. How do you bridge this structural gap without completely breaking your current code? Scenario 4. Let's go back to the text editor. User actions like copy, paste, and undo need to be encapsulated into objects themselves so that these requests can be queued, logged, or undone sequentially at a later time. What behavioral pattern turns a standard request into a standalone executable object?
Scenario 5. System chaos is unfolding in a corporate network. A printer spooler is repeatedly crashing because different Office modules keep trying to create their own separate duplicate connection instances to the hardware. You lack a centralized point of control. What creational pattern fixes this immediately?
And finally, Scenario 6. You simply need to instantiate a basic standard user profile object. There are no complex variations, there's no need for step-by-step assembly, and you certainly don't need a global access point. Think very, very carefully about your trade-offs here before you lock in your answer.
Section 4. Our step-by-step decision framework. Take a deep breath. Before we reveal the answers, I want to equip you with a repeatable mental framework to dissect absolutely any exam question you face in the future.
Whenever you're reading a prompt, run it through this 3-step checklist. Step 1. Isolate the problem type. Are you creating something, organizing something, or coordinating communication? Step 2. Clearly define your architectural goal. Are you aiming for decoupling or maybe flexibility? And step 3, the most crucial one, weigh the complexity trade-off. Does the pattern actually justify the extra code?
If you can visualize this workflow during your exam, you'll systematically eliminate the wrong options. Specifically, look at checking the trade-off. Does it solve a real problem? Will it reduce overall complexity or just add to the mess? Apply the pattern only if it's justified. Keep this flowchart locked in your mind.
Finally, Section 5, the Practice Suite Answer Key. The moment of truth has arrived. Let's see how your architectural instincts held up under pressure.
Let's see how you did. For Scenario 1's interchangeable algorithms, we use the strategy pattern. Scenario 2's dynamic wrapping requires the decorator. Bridging the legacy interface in Scenario 3, that is classic adapter territory. Turning actions into objects for Scenario 4 is the command pattern. Halting the printer spooler chaos in Scenario 5 absolutely demands a singleton. But the most vital lesson of all is Scenario 6. Standard object-oriented programming was the correct answer. Did you fall for the trap of over-engineering? Remember, the mark of a true principal architect isn't just knowing how to implement every single pattern, but having the wisdom to know when a simple, standard object is all you actually need. So based on today's masterclass, the next time you design a system, will you let the problem dictate the pattern, or will you force the pattern onto the problem?